Hello, I'm Chris, and today on Kersey Fabrications, my son has given me a challenge to build a Joy-Con holder the size of this Switch. Can I do it? Let's find out. So as I mentioned, this project was inspired by my son. He is an avid gamer, plays a lot of Nintendo Switch. And if you're unfamiliar with the Nintendo Switch, let's start by giving you a little bit of a primer on the system. This is a Nintendo Switch console. It's both a portable and an at-home system. It has a display built into the unit, and these Joy-Cons, these controller pieces, actually separate from the unit. And so basically the way this works is when it's portable, you play it like this. When you are at home, though, you can place this into a dock and then use something like this, which is a Joy-Con holder, to actually hold the two Joy-Cons. This actually has no other function. There's no electronics built into this. It's pretty much plastic and metal. The only thing that looks like electronics is these front pieces here light up to actually show you the IDs of your controller, but they're still dumb functions. These are just light pipes to show you what controller you're on. So, but he's an avid gamer. He goes back and forth a lot, and when playing fighting games, changing the look and the feel of the way that you're playing and the way that you're fighting can actually have an impact on your game. So he wanted to know, is there a way to create a Joy-Con holder that would have the same form factor as this unit? So I'm like, well, I'm not sure, but let's take a look at the design, let's see what it would take, and then we'll go on to doing some CAD work and some sample prints and see what we can do. So let's move on to design. So the real challenge when designing one of these holders for the Nintendo Switch is the Joy-Con connectors themselves. If you take a look on here and in the separate Joy-Con holder, what Nintendo has done is they've done these pieces out of metal. Makes them durable, makes them easily to reproduce, and they don't have to worry about them breaking. So can we produce these metal pieces in PLA plastic on a 3D printer? Well, if we can get that part to work, then we can probably produce these parts in a 3D printing environment. So let's go ahead, let's go to Fusion 360, let's see if we can put these together. So here we are in Fusion 360. Keep in mind this is not going to be a Fusion 360 tutorial, but more of a walkthrough of my design process. So first of all, I create a sketch of what I'm going to be working on. In this sketch, I'm going to dimension out the part that I want to create. So for this one, I want to start out by creating this part. I want to create the connector so that I can do some test prints of this connector because everything else is just plastic. But this has to be dimensionally accurate. So I'll go through with calipers. I will measure each of these down to the 1/10 of a millimeter. Anything finer than that, your printer's not going to really pick up. And I'll figure out which pieces of this connector are going to be on different levels. So the top part of this connector is one level. Then the walls of this connector is the next level. And then there's going to be the base of the connector that goes into the body of the Joy-Con holder. So as you can see here, I've got that designed out here. I have all the dimensions of what I think they're going to be. And then the last thing I do, once I've got it dimensionally spec'd out, I actually go in here and from anything that transitions from an opening to where plastic's going to be, I need to take into account my printer tolerance. The printer tolerance can be found out using Maker Muse's tolerance gauge. Most 3D printers are going to have a 0.2 millimeter tolerance. And so what that means is for like this wall here, which transitions from an opening to a wall, I'm going to take this wall back 0.2 millimeters. So that means this was originally 1.8. I'm going to make it 1.6 so that things can slide easier. And then I can come in here and tweak. If it's a little too loose, I can tweak these openings for my printer to make sure it's as tight as I want it to be. So once I've got this dimensioned out, I'm going to stop the sketch. From there, I can start extruding out my part. So again, I start with the wall, and that's this part here. And then I'm going to create the outer walls of that connector, which are here. That's this part here on the connector. Then I can create the back. And this is as big as I want this for now because I want to do test prints with it. I don't want it to be too big to where I'm wasting plastic on print after print after print, where I'm getting tolerances correctly, where I'm making the connector work. One other thing I wanted to point out is you can see it really well here, is I wanted to print this without supports, because with supports it's not going to slide all that well because there's going to be places I have to clean up. So the only thing on this connector that wouldn't be supported if printed vertically were these overhangs in this area here and here. But if I create a bridge here by extruding some extra plastic, then I've taken care of the problem of that needing supports. So then I need to create these light pipes, which are here so that I can see the ID of the controller. Then I extrude those light pipes out. Then I'm going to need to create them here on this wall and extrude them out here so that it goes around. Now if I want to be able to see those, I'm actually going to need to create some 45-degree angles so that it reflects correctly off that. Now from here I can run test prints and show you what my test prints look like so that we can see how many iterations this actually took me to get it right. So first thing, when I went to do the test prints before I started printing this model, I remembered that in the model that I created, the thinnest wall, the wall for that connector, was 0.6 millimeters. And because of that, I could not use a 0.4 millimeter nozzle, which is standard on most 3D printers. So I went and pulled out the pack of nozzles. You can order these pretty inexpensively on Amazon. Just make sure you order the nozzle kit that's correct for your printer. They come in different sizes depending on what type of printer you have. I could have either gone with a 0.2 or a 0.3 millimeter nozzle to do that 0.6 millimeter wall. I decided to go with a 0.3 mainly because I thought it would give me more structural integrity to the model, and the larger the nozzle, the easier it is to print with. The closer you get to 0.4, the easier it will be to print with without having to modify your settings a lot. So all of these models were printed with a 0.3 millimeter nozzle. The first one I printed was a thin connector. It was just thick enough to test what I needed to test. So with this, I was able to find out that the initial model I created was going to be too tight. And so I played with the settings a little bit. I moved the walls out, and the second model a little bit better. And at this point I wasn't sure whether it was the actual wall that would be the metal or if it was the spacing between that wall and the rest of the adapter. So tore that model in half and actually cut off a piece of one of those walls to do a test fit of just that component. After all, these are just test prints. We can tear them up, we can do what we need to do our prototyping. Once I sorted that out, went to the next model. It then fit, but was a little too loose. It moved, it didn't snap in. Finally, this model snaps in just the way I wanted it to. Fits tight, moves around a little bit, so I'm sure I made a small adjustment to the model so it didn't wiggle as much, but it snaps in just like I expected. On this model, I noticed, because I had the windows in place for the ID, you could see the light, but it wasn't bright enough without having to sort of, get down on it to see what it was. Made that final modification that I showed you in the last segment, where I put that 45-degree angle in there. Did one more print. Pretty great. So let's go see how I finished up this model and then show you the final result. So once we have that connector the way we want it, once that Joy-Con slides in and we're happy with this, the rest of this is basically the look and feel of it and plastic filler that's going to be setting the size of the entire controller. So the first thing we're going to need to do, we've got one of these, but we need the one for the other side. So we're going to do a mirror function and create the other one. Then we're going to move that the distance we want it to be apart. And then from there, we can extrude out one of those faces to connect it into one part. So now we have basically what we've been looking for. Now let's make it look nice. Let's give it a good feel. So we're going to do some fillets on the edge. Different fillet on the other side. I actually was looking at the original holder to try to get these angles to feel the same way as the original ones do, the ones that you actually buy from Nintendo. Then I created these. The original one had it. It's good for strength by creating a fillet here, creating a better transition between the parts. And then, you know, this is kind of plain. So my son's big into Smash Brothers, so let's add a little bit of graphics, a little bit of design to this controller. And what we have here is the final product. These actually help tell you which side the Joy-Cons go on. These actually represent the joysticks on each of the Joy-Cons. And then we put the Smash Brothers logo here in the middle. Now we're ready for our full print. And it should go well, considering the fact that we've already tested the connectors. Let's see how it went. For this final 3D print, I really wanted to use a filament that would be a strong plastic, something that could really stand up to everyday use on a kid's console. So for this, I was contacted by a company, Coex LLC, and they not only have great PLA filament, they also are working on an experimental filament, a tough filament called XT PLA Badger. And this is a super tough filament. It's printed a little bit hotter than your typical PLA. For my print, I printed at a 225 nozzle, 65 C bed, and I had it at a 96% flow rate. I was only able to print at about 40 millimeters per second, but that had as much to do with the fact that I was printing with a 0.3 millimeter nozzle as it did with the filament. And for this print, I went, I don't remember, I went with either a 15 or a 20% infill. And so our final model, here it is. Turned out overall really, like, the model is super solid. It's a tough model. These pieces here are not going to break off. And the only artifacts that I really found in the final print were some ringing because of these long straight runs, as well as just one print all the way, one layer line all the way around that it was just a little over extruded for some reason. Doubt it had anything to do with the filament, probably had more to do with the printer. So let's see how it works. So right Joy-Con, you hear it snap on. Left Joy-Con, you hear it snap on. And then once these connected, you can look in these holes and actually see which ID that these received. And for comparison, we have the original gamepad and we have the new adapter. They both put the Joy-Cons about the same distance apart, and so it really will feel like you're using the original one, although it's going to be a little bit lighter, which should be good over time to avoid fatigue when gaming. If you'd like to download this model and try it out for yourself on your 3D printer, I'm going to have this available on Thingiverse. There'll be a link in the description, and you'll be able to download one of two different versions. There'll be a blank one, which you could print the way it is or add your own logo to, or you'll be able to download the Smash Brothers one, print it like the one I did for my son. Now, if you'd like to also support Coex, who sent over the filament for this this project, then you can purchase their PLA on their website. I'll have it in the description. If you purchase $49 or more, I also have a code for you, Kersey Fabs. You'll find that also in the description, and that will give you 15% off that order of $49 or more, just as a thank you for them sending over this filament for this channel. If you'd also like to try out their tough PLA that I printed with, it's not available for sale yet, but let them know that you saw this video, and with your PLA, your regular PLA purchase, they will also include a 100-gram sample for you to try yourself. just put that in the order notes field when you place your order. That does it for this video. If you enjoyed it, please hit that like button. Also, in the comments, let me know about what you thought about the format of this video. This is the first of this kind. I've got many more to go. Let me know if you enjoyed the walkthrough that I did. If you like this kind of project in terms of like video game consoles, let me know what you'd like to see on this channel. Again, thanks for watching. Subscribe to my channel. I've got more coming soon. See you next time on Kersey Fabrications. Hello, I'm Chris, and my wife writes all my best lines.